So, our colleague from India was indeed part of our closing session. So we hope that the buses will be back or somehow we will establish collaboration and he will come to Serbia and present everything in live. So I would like to give you some indeed takeaway tips from these 2 days and somehow reflect to what our colleagues from Europe have presented us, so I'm this time on the side of Pupin. I would like to explain the motivation for going in the direction of big data, somehow studying these topics, what are the benefits for Pupin, and to present you some of my personal work in the last year. Those that were present at the first Big Data Analytics summer school, we somehow invested a lot in defining what is knowledge graphs. So we did not indeed repeat this time the same. But in this talk, first I would like to point to some other terms that we have indeed used the last 2 days and somehow are not sometimes clear what is what. So I will give some light on the definition: big data ecosystem, big data analytics. And also I will just point to some results of the survey that we have done on applications, and also takeaway tips about research trends. Indeed, this is a summary of the colleagues from Europe. The goal of Lambda is really to advance the state of the art. So all these techniques that were presented today, they are state of the art techniques. So for the newcomers, it's difficult indeed to somehow to position which techniques is going where and why do we need that techniques. Maybe we will have additional questions to you after the summer school. Please, everybody who would like to ask something, our colleagues from Europe, please post to BDA school mailing list. One of the goals, let us, when we are here today, demystify the term big data ecosystem. What is for you this big data ecosystem? What is for us? What is for the company's big data ecosystem? So we have heard about the definition last year as well. Big data is, and you all know the definition, big data is a high volume, velocity and variety data assets that demand cost-effective, innovative analytic solutions to process the data sets in order to get some insight. But how big this data set should be in order to consider a big data? So big data for Amazon and Google is something different than big data, for example, a company in Europe or a company in Serbia. So let's talk about that and open the discussion until the end of the summer school today. So some of the statistics that one can find on the web. So in 2010, big data size was standing at 1.2 zettabytes. In 2019, there were 2.3 billion active Facebook users, and they generate a lot of data every second and every minute and every day. So 90% of all data has been created in the last 2 years. So according to IBM review. So Twitter users sent over 500,000 tweets every minute. 40 zettabytes of data will be created in 2020. And according to IDS forecast, so it will be 175 zettabytes by 2025. So that is indeed big data. So big data analytics. So what is big data analytics? So we are talking about analytics. So knowledge graph, is that big data analytics or it's not big data analytics? But just to point to the work of American scientist Thomas Davenport, he has classified analytics into 4 eras. So the first era started, it's written here, started in 1975, but it really started before that, because we have in journals definition about analytics and descriptive analytics long before that. So he said the second era of data analytics started in 2001, and it's somehow overlapping with semantic web, overlapping with NoSQL stores, so Hadoop and other technologies. And Analytics 3.0 started with 2013, according to Davenport, with the Internet of Things, where the Internet of Things became live. And now we are in 4.0. It overlaps with Industry 4.0, which overlaps well with what Anastasia today pointed. She said this standardization of these mapping languages, it's occurred in the last few years. One of the motivation here in Pupin why we are studying big data is because our clients are in the domain of big data. So we are managing the energy sector in Serbia. So it's really petabyte of data that is collected, and we have to be aware of all the technologies that exist out there in order to apply in our solutions. So we are analyzing the applicability changes for exploiting the potential of big data for our clients and for our solutions. So the research methodology in Lambda. So we are studying the tools here in Pupin also, and our colleagues. We have started to build this catalog of big data tools. So if you come to Big Data Lambda web page on learning and tools, you will find one session of these tools. We are studying the research trends, and in all chapters that are delivered with the book, you will find one section on research trends. So research trends are studied or delivered in the chapter of tools by Hadjura, that they are delivered in the chapter of federated querying by Professor Vidal, and so on. And based on all this that we have discovered in the last 2 years, we will prepare some recommendations first for us, for Pupin, and then for our stakeholders here in Serbia and West Balkan. What the consortium is doing is we are working on prototypes. So we are developing prototypes, and our partners presented some of their work during these 2 days. More of this is confidential, and it cannot be really presented. But we had also last year, Furche was talking about his web extraction algorithm, so it's really confidential. So that is why we pointed to his papers, but the real application is really we cannot present public. So on the survey of big data, if one retrieve the Elsevier database or retrieve the Springerlink database, so you will find a lot of review papers and a lot of academic papers on big data or somehow related to big data. So we somehow checked the papers, and in these papers you will find the term ecosystem defined as a complex network of interconnected systems. So while in the past corporation used to deal with static, centrally stored data collected from various sources, with the birth of cloud services, cloud computing is rapidly overtaking the traditional in-house systems as a reliable, scalable, and cost-effective IT solution. So large data sets, log files, social media sentiments, clickstreams are no longer expected to reside within the central server. That is why we opened the topic of lakes today. So these data resides on the cloud server. They are hosted by Amazon or some other host providers. So to cope with this, to handle this copious amount of data, advanced analytical tools are needed, and that is why we are experimenting with new technologies. On the web, you will find this data. Some of this data, I cannot say that is true or not true, but is published in the papers, and you can find on the web. So Facebook in 2017 has more than 2 billion users of 2 billion users on millions of servers. LinkedIn in 2017, more than 400 million members worldwide. 100 servers split across multiple data centers. Alibaba, the second largest hosting company in the world. Google in 2016, according to Gartner, estimated that Google had 2.5 million servers and 40 million searches per second. And Amazon in 2014, an estimate that they had 87 data centers with 2.8 and to 5.6 million servers. So these are data that I have found on the web. So I'm just presenting what is in the literature or on the web. How fake is it? I really don't know, because I'm not so involved in these circles. So we talked today, and this in the last 2 days, about the analytics, different kinds of analytics. Professor Maria Esther talked about integration. The question was raised: why do we need this semantic layer? Why do we need the knowledge graph? And my answer was the knowledge graphs in the literature and in practice, it's live technology. So knowledge graphs are live technology for Google, for Microsoft, for Amazon. So we don't have to, we have to admit that. So they are collecting data, not just from their corporate data systems. They are collecting data that is found on the web, on Twitter. So all this data is collected, merged, and they are using semantic technologies, or their technologies maybe it's not RDF knowledge graph, but that it is semantic knowledge graph created in 2012 by Google. So in that moment, indeed, the knowledge graphs were popular, some became popular. So on the right side, also in these 2 days, we presented some of the applications. We tried to cover healthcare. We tried to cover to mention social networks. We had now a presentation from traffic domain, but there are many industrial applications that are exploring also knowledge graphs, pharma industry especially. Last year we had Atanas Kiryakov, and his company Ontotex is very successful in the pharma domain. So we talk about different kinds of analytics. I will just skip this. If you go, as I mentioned, scientific Elsevier Science Direct or Springer Link, you will find a lot of results about big data. According to my analysis, you can see here the number of papers I retrieved this year in April. It was 10,000 review papers. So it is more than 100,000 papers on related to big data, but these numbers are from Elsevier database. So if you look for big data analytics, you will find 10,000 articles, and these are review articles in the category review articles. But if you look for papers that contain big data analytics, business intelligence, you will find papers from from the 90s of the last century. But if you're looking for NoSQL, you will find papers from the last 10 years. So when the NoSQL became very popular, when Hadoop really took over the markets, And now we have also applications in the last 10 years, also with big data analytics and NoSQL. If you're looking for journals and big data applications, where are these big data applications? They are not just related to decisions. The big data analytics is not just related to decision support system. Big data analytics is related to chemistry, is related to chromatography, to medicine, nuclear physics, and geographical information systems, as we discussed yesterday. So big data is really across many industrial domains. So analyzing what is important for Pupin, some of the applications are in e-government, healthcare, transport, energy production, as we mentioned yesterday, energy consumption, bank and insurance as well. Social environment monitoring, natural disaster safety and security. We are working in that area as well. Telecommunications and manufacturing. We already have some Horizon 2020 projects using big data and artificial intelligence manufacturing. So somehow out of the scope is nuclear physics, astrophysics, material science, then chemistry and chromatography. But as I mentioned, big data is more than, and big data analytics is more as that we can somehow deal with in Pupin. So we are following the recommendation from European Union about data strategy, big data in energy domain. We discussed that yesterday. About transport and smart cities, the presentation of the buses was just one light on this aspect, because big data is very much used for managing large cities. So increasing number of cities around the world struggle with traffic congestion, optimizing public transport, planning parking spaces. So this is really a vertical of applications of big data. Highways and motorways control systems are based on big data, self-driving cars, because you have a lot of sensors that you have to collect and merge, and and maybe also traffic lighting in cities. So problems that are challenges is how to prevent road traffic congestion, as also the buses pointed, how to prevent road accidents. Strategic environment impact, because with a lot of people and cars on the roads, we have really a problem with the environment, flora, fauna, and soil and water. So passive pollution monitoring is based on and big data. About energy management, I will also skip this because Nicola talked about that a lot yesterday. He didn't mention in between platform and in between project. He is in the domain of energy consumption, home automation. And challenges here are to provide optimal device scheduling to maximize comfort and minimize costs, planning and offering possible home adjustments or suggesting improvements in renewable sources. So how to, when to plug in the photovoltaic, or when to connect to the grid. I would like to point to the work of Amazon in the domain of knowledge graphs. So they are using the Amazon product graph has 100,000 product types, 5,000 attributes. So this is a big data graph. And so they are pointing to these challenges in building the knowledge graph, that we really don't know what we want to model and what is the underlying schema. So this is the question that Professor Maria Esther raised today. So we really don't know how this underlying schema will change, will evolve. So a lot of problems appear on the knowledge graph level with the evolution of the underlying schema. So too little structured data. So we talked about that last year. Tim Furche pointed to the problem of extraction of data from the web. So Amazon pointed to this problem on a second point. So this is second major issue for them, because they are collecting and they are somehow looking on the web what exists there, and they are collecting data from there. Heterogeneous data is heterogeneous, as we discussed today. So how to extract the data? Is the data trustworthy? Scalability, we mentioned about that. So on challenge on the seventh plane, how to train the machine learning model, because this was also the issue that was raised yesterday by Professor Gloria. She said, let's look and take fuzzy logic. Let's use fuzzy logic for that. Then how we have to understand the user needs. How to get insight from all this data you will collect, how to get insights to give to the user, to the end user, and how to explain, as we discussed already. About the environment monitoring, in the presentation of Gloria, we heard about the big data that is collected every day by NASA and by also Copernicus program. So 20 terabytes daily observations, satellite maps and everything. So this data gives the opportunity for building big data applications in smart farming, rainforest monitoring, biodiversity planning. So I'm just pointing to some of these applications. There are a lot of that are not even covered. We try to cover something in the Lambda book, but we really cannot cover everything because it's really a big data, big domain, big problems, and big explanation. I mean, we have to really to write a book of 1,000 pages to explain everything. So the domain of safety and security very important for big data, because we have to integrate multimodal data, images, audio, text, similar as was presented in the medical domain yesterday. So we have to synchronize the activities of many stakeholders. We need to install measuring devices to collect all the input. We have to build mobile applications to give the mobile applications to first responders, to people, to citizens, so they can alarm. We need to have visualization information for the first responders. So big data problems, a lot of big data problems really in the safety of critical infrastructure. One of the areas that is important for pooping. So because big data processing is important for airports, for railway, metro systems, power grids, and our products, pooping products, are installed on in this critical infrastructure in Serbia and also abroad. Besides processing of large amount of heterogeneous data extracted from multiple sources, challenges are real-time visualization, as I mentioned, semantic analysis, how to develop and adapt these new tools. Scalability is a problem. And lately, we are looking also in the domain of Industry 4.0 and manufacturing, how to adopt industrial data space initiative here in Serbia. We had the presentation yesterday from Simon, who is from Fraunhofer, and we really thanks to everybody and who was participating in these 2 days to somehow to demystify the problems with a lot of tools in big data domain in the landscape, a lot of reference architecture, which architecture to use, so it's a question. So this is one of the results of the Lambda and with our colleagues from Fraunhofer and the consortium, we tried to build around manufacturing. We built architecture and we have this layer architecture here. When on the bottom we have the data management, machine learning is a separate layer because we have to collect all this data and provide explainable models for the end users in manufacturing. So with big data, it was also presented today in Emmanuel's talk, we can build knowledge or cognitive services. So cognitive services for monitoring and early warning, cognitive services for fault detection, predictive maintenance, self-adaptive capabilities. So where are the knowledge graphs here? So this is once maybe a question. So where are the knowledge graphs here? Are they on the cognitive service level or machine learning level or on pre-processing level when we have to elaborate the mappings? So in the manufacturing scenario, very important is human-computer interaction, because now it's going in the direction of, so as we had in robotics yesterday, so we are going in the direction of natural language processing and dialogue systems. So these dialogue systems works on big data as well. Then a dynamic process adaptation, when we have this well-established, for example, processes in the factory. So how we can very easily change the process. If we have a flexibility that these new technologies as knowledge graphs is given, so we are not fixed to some schema in the relational database, but we are really flexible. We can very move from one production line to another. If we have, for example, description of the plant in knowledge graph. So takeaway tips. Challenges can be divided into data challenges, as we discussed, related to data volume, variety, velocity, volatility, quality, value. Process challenges related to technologies. So which technologies to use to build your process chain to ensure end-to-end processing. Management challenges, we didn't discuss a lot, but we said that we have privacy, security, governance, ethical aspects should be taken into consideration. Summary on trends. So this you will find in the literature if you dig in, but also from my experience, because I was involved in developing operational data management systems, I can say that the focus is shifting from operational data management systems, data warehousing, warehouses, and business intelligence solutions. I developed business intelligence solutions in the 90s, to parallel and distributed computing. So we are moving on the cloud. We are moving to the services are moving on the cloud, or we need distributed solutions, distributed tools. One database or data warehouse is not enough to solve the problem. Emerging trends, an emerging paradigm, the Internet of Things and blockchain, additional influence, cloud computing, and wide availability of cheap processing power enabled progressive breakthrough in machine learning, semantic technologies, artificial neural networks, multimodal affective learning, and intelligence. End-to-end processing, it was somehow a takeaway note from a tip from Simon. Data lakes are reality. So data lakes concept is reality. Semantic data lakes concept is following indeed. We learned about semantic data lake today with when we talk about federated querying and everything. So you can look at the report of TDWI, Transforming Data with Intelligence website. Hadoop technology will soon become a common our standard that will not replace the existing product. They will not replace Oracle. They will not replace Microsoft SQL, but they will live side by side. They will deliver a solution side by side with business intelligence solutions that already work there, with data warehousing solutions that already work in the companies. So just a summary on the left side are the domains that are very important for Pupin, but I would like to point once again to energy. It's very important for Pupin, and all the technologies that we discuss in these 2 days will be tested, and we are already underway to be tested in Platoon. We are collaborating in Platoon in the same consortium with University of Bonn and University of Bonn and Fraunhofer Institute. And I would like to ask you to, once we release the chapters of the book, to come and to download the materials. I would like to thank once again to the European Commission, because they funded us indeed to develop all this and to prepare these lectures for you. I would like to open the question and answering now, and I see that we have one question. No, we don't have a question. So please, if you have some question for me or for others from the consortium, please discuss. Otherwise, I would like to close this, the Big Data Analytics Summer School 2020 and ask you to come and visit us, to follow us. We would like to prepare the third edition, but stay tuned because we have indeed to elaborate the plan. So any feedback? Okay. Then I would like to thank you all for these 2 days. They were productive, and I think that you have learned, our PhD students, you have learned a lot, and I would like to thank our speakers. Thank you. Thank you very much.
Thank you to you. Thanks to you.
Thank you, Valentina, for organizing. Thank you very much.
Thank you.
We have indeed in the call Daniel Pop. I would like to ask, he's in our advisory board. He was listening to us yesterday and today. So please, Daniel, if you want to give your feedback.
Yeah, hello everyone. I was pleased to join those sessions, and I can say that from each of the lectures giving, I had some takeaways to learn, and some new things were provided, were delivered to the participants of the session, even for those who have some experience in the field. So there were interesting presentations. Thank you, Valentina, for organizing this in these conditions with this pandemic. And on one side, it was, I guess, easier for participants to join and present. And we had good numbers of participants to these lectures, but unfortunately, we are missing the face-to-face interactions and the networking that's was very good last year when we were in your place, where you hosted us in Belgrade.
Yes, I hope you will return back, Daniel.
Yeah,
I hope
to see you soon for the next event, and I was very pleased to join in these 2 days. Very good.
Thank you. Then stay safe and healthy.
Same.
Thank you. Bye-bye.
Bye. Bye all.
Bye.